Good day, viewers. You are welcome. How to solve these algebraic equations where we have x to the power of 8 minus x to the power 2 divided by x to the power of 4 minus x to the power of 2 equals 1. So to solve this, we have what is common here, which is x to the power of 2. By factoring out x to the power of 2 here, then here we have, when we divide this one by x to the power 2, we have x to the power of 6 minus, when we divide this one by x to the power of 2, it remains 1 divided by, also we can divide both sides by, we can factor out x to the power of 2, then in the parentheses we have x to the power of 2 minus 1 equals 1. So if this is what we have, x squared cancelled x squared. So then we have x to the power of 6 minus 1 divided by x to the power of 2 minus 1 equals 1. So on getting to this stage, what we are going to do here is, suppose we have x to the power of 6 minus 1 to the power of 6. So divided by, here we have x to the power of 2 minus 1 equals 0. So then, from this numerator, which is x to the power of 6 minus 1, we can write that one as x to the power of 2 raised to the power of 3 minus 1 to the power of 2 raised to the power of 3. So that is according to the rule of indices, divided by x to the power of 2 minus 1, everything equals 1. So when we consider what we have above as the difference of two cubes, where we can consider this expression as a to the power of 3 minus b to the power of 3, this is given as a minus b in bracket, open bracket, a squared plus ab plus b squared. So this is the identity for difference of two cubes. So when we apply it above, as a is our x squared and b is our 1 to the power of 2, then we write it as, considering this one only, we are going to write it as x to the power of 2 minus 1 to the power of 2. This in bracket, open bracket. So we have x to the power of 2, then this one also raised to the power of 2, plus a, which is x to the power of 2 multiplied by 1 to the power of 2, plus, so we have b, which is 1 to the power 2 all raised to the power of 2 in bracket, divided by x to the power of 2 minus 1, everything equals 1. So let's try to rewrite this. We have this as x to the power of 2, so 1 square is still the same thing as 1 in bracket, x to the power of, when we multiply 2 by 2, we get 4, plus then 1 to the power of 2, that is 1, multiplied by x squared, so we still get x squared, plus also with this one, we have 1 to the power of 2 times 2, that is 4, and 1 to the power of 4, that gives us 1 as well. Then everything in bracket, divided by x to the power of 2 minus 1, everything equals 1. So suppose I bracket this one also. So this and this cancels each other. So and at the top we have x to the power of 4 plus x to the power of 2 plus 1. Everything equals 1. So at this stage, 1 cancels 1. So and here we have x to the power of 4 plus x to the power of 2. Everything equals 0. So next, let's say we factor out x to the power of 2 here. So here we are left with x to the power of 2 plus 1. Everything equals 0. So I'm looking at this one. We have two cases here. It's either we let x to the power of 2 equals 0. And by taking the square root of both sides, so we have x equals 0. So here is what we have first. And also for this one, x to the power of 2 plus 1 equals 0. So by transferring 1 to other side, we have x to the power of 2 equals minus 1. Then we take the square root of both sides. So by taking the square root of both sides like this, we have this as plus or minus the square root of minus 1. So having this cancelled, as we have our value of x equals plus or minus square root of minus 1. But square root of minus 1, it gives iota. So therefore x equals plus or minus 1 is what we have for other two solutions. So which means the highest power of x we have here is 8, but we only get 2 solutions. Alright? Because when we consider x equals 0, it will not satisfy the problem, as it leads us to undefined. So it is only when x equals to plus or minus I that satisfy the problem, which means the roots are complex. So and this is how to solve this problem. I hope you learned something today. Thanks for watching, and if you are new here to this channel and you find this video interesting, please do well to like, share and subscribe. See you in the next video. Never stop learning. Bye bye.